Tutorial 8, question 2. Solve the following equations for theta in the range theta is greater than 0 and less than 2 pi. Part A is like question 1. We've got cos theta minus sin theta equals minus 1. So let's deal with the cos theta minus sin theta first. So we know that r sin theta plus phi is equal to r brackets cos theta sin phi plus sin theta cos phi, close brackets. So if we let cos theta minus sin theta equal that, we can see that we've got cos theta here and a cos theta here, so r sin phi is equal to 1, and we've got sin theta here and sin theta here, so r cos phi is equal to minus 1. So we can find phi by dividing r sin theta by r cos theta. The r's will cancel and we get sin phi is equal to 1 over minus 1. This is y over x. So let's draw a quick sketch to see what we're talking about. Y is equal to 1, x is equal to minus 1. So our angle is going to be greater than pi over 2, or greater than 90, and less than pi. If you put this value into your calculator, you'll get minus 7.9, or minus 45. And the reason for that is that the calculator can't differentiate between minus 1 over 1 and 1 over minus 1. So knowing where the angle is, we're going to add pi radians, or 180 degrees, which gives us the angle there of 2.36 radians. For the radius, we're going to square these two quantities, and sine squared plus cos squared is equal to 1, so we're going to get r squared is equal to 1 squared plus 1 squared, so that's the square root of 2. And the square root of 2 is 1.41, which means that cos theta minus sin theta is equal to 1.41 times sin theta plus 2.36 radians. Our question says that cos theta minus sin theta is equal to minus 1, so now we can write 1.41 times sin theta plus 2.36 is equal to minus 1, and we can solve that for theta. So the first thing we'll do is divide both sides by 1.41, and then we'll take the arcsine of both sides. So theta plus 2.36 is equal to the arcsine of minus 1 over 1.41. We'll take the 2.36 onto the other side. We'll evaluate the arcsine, which is minus 7.9, and then if we subtract one from the other, we end up with minus 3.14, which you probably recognise is minus pi, or minus 180 degrees. Remembering what sines and cosines look like, we can add 2 pi to this answer without changing any of the values, which means that we've got an answer of 180 or pi. Here's the graph of cos theta minus sin theta equals minus 1, and there's minus 1, and there's our answer. But notice there is another answer here, and actually if you think about it, it's an infinite number of answers because the sine wave just carries on to infinity. Why didn't we find this answer? Well, the reason we didn't get this answer is because of the way we added pi radians here to get our value of phi in the range 0 to 2 pi. And then finally we have the answer to the other questions. And that's the end of question 2.